Good morning, students. There were already that we had studied about the Ohm's law without taking your more time. Okay, the Ohm's law that we had studied is based on the temperature, type of the material, nature, humidity, and all. But we required some basic laws which are more fundamental. Therefore, the Kirchhoff has given the two laws of the electricity. The first law is the Kirchhoff junction rule. The second one is the Kirchhoff loop rule. Before going to discuss about the junction and loop rule, just we are going to discuss about what is network, loop and junction. So very first thing, what is network? Network, that is a complex arrangement of resistances, batteries. Okay, either they are connected in series or they are connected in parallel. They are connected in series or they are connected in parallel in a simple manner or in a complicated manner. That is known as network. Or in this network we are having a closed path. For example, A, B, C, D, E, F, A. This is a closed path. This is a closed path. So how many loops are there in this circuit? This is the one big complete loop, A, B, C, D, E, F, A. Okay, the two other small loops, this one, A, B, E, F, A, A, B, E, F, A, and the third loop is B, C, D, E, B. Again, the points from where we have to start, and after completing the entire one loop, we have to again come back. So this is known as loop. A closed path formed by the conductors is known as loop. And what is junction? A point where more than two conductors meet is known as junction. A point where more than two conductors meet is known as junction. तो कौन से दो junction हो गए यहाँ पे? B and E are the two junctions. So B and E are the two junctions. And on the basis of this loop and junction, Kirchhoff has given the two laws which are more basic and more fundamental. The first one is the Kirchhoff junction rule, or it is also known as the Kirchhoff first law. And this law is based on the law of conservation of charges. We all know that for an isolated system, the algebraic sum of the charge remains constant, or in current electricity, the amount of charge enters from the one end of a conductor is equal to the amount of charge leaving through the another end at the same time. So here we are taking a junction at O, which is made up of the 5 conductors carrying electric current I1, I2, I3, I4 and I5. And direction of the current is as shown in the figure. I1, I3 and I5 approaching the junction, I2 and I4 leaving the junction. I am again repeating, I1, I3, I5 approaching the junction and I2 and I4 leaving the junction. This means that the amount of charge which enters at the junction is equal to the amount of charge leaving the junction. So amount of charge kitna? The Q1, Q3 and Q5 entering, Q2 and Q4 leaving. The Q is equal to IT. Therefore, you can say that in time t, I1, I3, I5 is equal to I2 plus I4. Simple. Or we can say that the algebraic sum of electric current passing through a junction remains the 0. So, at any junction, the sum of current entering the junction is equal to, it is junction, is equal to the sum of current leaving the junction. Kirchhoff first law is based on the law of conservation of charges. जितना चार्ज आएगा उतना चार्ज जाएगा, तो algebraic sum of current is 0. आने वाला current is to be taken as positive, जाने वाला current is to be taken as negative. I hope you can able to understand the Kirchhoff junction rule. Okay students, now you already understand about Kirchhoff the junction rule. Now we are going to discuss about the Kirchhoff loop rule. Okay, and already you know that what is loop? A closed path formed by the conductors is known as the loop. So this law is based on more basic, it is based on the law of conservation of energy. And what is the statement? In the first law, the algebraic sum of the current passing through the resistor is, passing through a conductor is 0. Here the algebraic sum of potential remains 0. The algebraic sum of the change in potential, the word is very important, the algebraic sum of change in potential around any closed loop which involves resistors and the cells, and the loop is 0. Here current is 0, here the change in potential delta V is 0. But when we are discussing this, when we are using the loop rule, then we have to follow certain sign convention. Here we have used आने वाला current is to be taken as positive, जाने वाला current is to be taken as negative. Here we are involving to resistor and cell. So here we have to take, suppose when we are moving in the direction of current passing through the resistor, listen, it is very important. IR is I and R. I current, R is the resistance, and we are moving in the same direction of the flow of current, then potential decreases and potential is represented by minus. And in opposite direction, see, current is moving from left to right, and here the direction of the arrow is from right to left. It is in opposite direction. Opposite direction में potential decreases. The reason behind this, the current is always moving from higher potential to the lower potential. So higher to lower potential always decreases. That's why V is minus IR in the same direction from higher to lower. From lower to higher it is increases. Therefore it is to be taken as plus. Sorry. Potential decreases. Here potential increases. Similarly, we are talking about the cell. So when you pass through this cell from negative terminal to positive terminal, unit positive charge gains energy. So V is equal to plus E, that is E is the EMF of the cell. And when we are moving from positive to the negative terminal, its potential decreases. So I again repeat. So Kirchhoff loop rule, the algebraic sum of change in the potential around any closed loop involving resistor and cell is 0. It is based on the law of conservation of energy. Sign convention is very important. In the direction of the current passing through the resistor, potential decreases, and in opposite direction potential increases. From negative terminal to positive terminal, potential increases, and from positive to negative, potential decreases. Okay, the first law is based on charge, second law is based on energy. Here algebraic sum of current is 0, here algebraic sum of potential is 0. Here very important is the sign convention for resistor, for cell, here for current only. I hope you can able to understand this. If you have any doubt, then please call me or contact me on my WhatsApp number. Thank you.